Hello, everybody on Earth. Welcome from the Moon and Mars. So I'm Bernard Foing. As I mentioned, I've been working at the European Space Agency. Now I have started an endeavor. This is the EuroMoonMars Earth Space Innovation, and I'm professor in various universities. And I would like to share with you how we can work together towards EuroMars 2022, but also future Moon and Mars villages. And so I have a number of quotas that are some young professionals, but also some senior researchers, engineers that have worked on this project in the last 12 years. I have a great pleasure to participate to this Rutherford Appleton Space Conference, as in fact, I have spent quite some time with you at the time of the preparation for the SO observatory, and then later for the preparation of the Smart One the mission to the moon, where there was an experiment from Rutherford. And indeed, we have tried to follow on some of this path of science, technology, exploration, even toward the human expansion into the space. So let's some little memories of our Smart One mission. The first satellite sent this millennium to the moon, and it was done by the European Space Agency, with a number of partners in terms of instrument and industry. And after 3 months, as you know, we launched with solar electric propulsion. So first we had to go very fast to escape the radiation belt. We took our first picture of our planet, and we focused on Europe. And on this picture, you can see very well that UK is part of Europe. And I have put also the little R, which indicates where Rutherford is, compared to E, which is where STEC is, where I have been working for the last 30 years. So a mission with a 370 kilogram spacecraft, a new ion drive, a new way to drive into the solar system, very miniaturized instrument like the KICS X-ray instrument that we had on board from Rutherford, infrared cameras, and so on. And with this, we explored the moon. For the first time, in particular, mapping the polar region on the moon. And we could find very interesting places where you have a permanent darkness, where later some deposit of ice have been found. But also, we found very interesting geological features, and very close to the South Pole, a place which is in almost perpetual sunlight. We called it the Smart One peak of light, as we discovered it with the Smart One spacecraft. So for the next step, if you want to build a robotic lander, that's a place where many people want to go. And indeed, at the time of Smart One, we also started some international links with colleagues from all over the world. We had American, Russian, Japanese, Chinese, Indian, and all over the world scientists and engineers using our data. But also at that time, we were the only one around the moon, and we connected with the next mission that were launched. In particular, there was a Chinese mission, Chang'e 1, and there was also the Kaguya mission from Japan that was launched in 2007. And in fact, we established also a strategy for sharing the access to the ground station from Europe so that we could duplicate the amount of data for the subsequent mission. Then I was in charge of negotiating the contribution of ESA to the Chandrayaan-1 Indian mission. And here, again, we had an experiment from Rutherford called DKICS, which was a kind of a little brother of the KICS, little brother of the DKICS experiment we had on Smart One, and we flew that on Chandrayaan-1 with the Indian. So 25 years ago, we started to coordinate between space agencies, academia, also industries, how we would go toward the settlement on the moon. So we call that the Moon Village Roadmap, with a series of mission in orbit precursors like Smart One and the other orbiters. And we had de facto, this millennium sent a fleet of orbiters, more than 12 missions. The next step is a surface robotic village, where you have various landers and rovers and various assets on the surface that can also start to deploy bigger infrastructure. And then we'll have a phase with a human outpost, and then a permanent and sustainable, that's for Harriet, sustainable presence in the international set of moon bases with human and rovers. That's what we call now the Moon Village. And so how could we start to contribute to this project after we had done the Smart One? there at that time we had this Google Lunar X Prize. So you could win 30 million by landing with a commercial company to the moon. So we built one of these lander, and in particular, we look how we could test instruments on board, like cameras, spectrometers, rovers, and so on. And we did that with a team of young professionals in collaboration with STEC and also with the Business Incubation Center, STEC, a bit equivalent to the RAL cluster that you have now, And every year we had a series of activities called EuroMoonMars workshop, where organized everybody, scientists, engineers, botanists, astronauts, even artists and designers join our group. So we have done some tests about cooperative robotics. So how you can deploy 2 rovers from a lander, and with this family of 3, how you could perform some operation for future science and exploration. And de facto, the robotic village has started. As some 7 years ago, in 2013, the Chang'e 3 lander landed and deployed a rover, U2, the Jade Rabbit. And actually, the lander is still in operation after more than 7 years. So de facto, we have had a permanent robotic surface presence on the moon. And this is going to continue forever. We have also built our own lander, as you know, and we have our lunar astronaut that has tested it. This is done in an analog field volcano that is a 3 hours drive from ESTEC, close to the European Astronaut Center. And we have done a series of campaigns to study this partnership between human, lander, rover, and instrument. And now we started 12 years ago this EuroMoonMars analog research program, where we go to places like Mount Etna or Hawaii or Utah, Mars Desert Space Station, or even Atacama or Iceland as places that are similar to the moon and Mars, and where we can test instruments, and even we test astronauts activities, and we also build some habitat in these places to prepare us for the time when we are going to live on the moon and Mars. So the latest is this base that is in the midway to the summit of the Mauna Loa volcano in Hawaii. So it's completely self-sustained, and you have solar power. It is beautiful volcanic landscape, very reminiscent of the moon and Mars. And it's now, it's belonged to the International Moon Base Alliance that was founded by Hank Rogers, so owner of Tetris, which is investing some of his money towards sustainability and towards exploration. And I'm also one of the directors of this foundation. And so we perform a series of short mission, like 2 to 4 months, where we change the technology, the investigation, in order to learn what you could do in a short duration campaign on the surface of it. And so I was there since 2018, and then 2019, we had a series of campaigns. We call them EuroMoonMars and International Moon Base Alliance, IC, the name of these facilities, also EMIS. And I have some young professionals doing their master research or their PhD research, training as a lunar astronaut in the field. Here you can see some 2 geologists taking some samples, documenting them before they bring them back to the base for analysis. We have also a strong collaboration with the German Aerospace Center at ESA for a campaign of telerobotics training and analog research. So this took place already in Mount Etna in 2017. And actually this group is a dual group. There are some activities in underwater robotics and an activity over planetary robotics, and there are quite some nice synergies. But here for this campaign, we went to Etna and we deployed 2 intelligent and autonomous rovers that could communicate with a lander and bring from a lander a series of instrument boxes, seismometers, and cameras. And we will have another campaign which was postponed because of COVID 2 years, but will take place in June 2022 in Etna. We'll have some 3 rovers, 1 operated by ESA as well, some number of drones, number of telerobotic system, and we deploy some instrument for analyzing samples. Even we deploy a radio interferometer with 4 radio antennas. So this will be a good preparation for the ExoMars mission with the Rosalind Franklin rover, on which there is this faster payload with a set of instrument suite with camera, spectrometer to characterize the area, and also a drill that allow to have a material from 2-meter depth, which have been protected from the effect of radiation, and where you could find molecules and even traces of ancient or extant life. So actually, we did a project this year with in times of pandemics. So luckily, I had some 4 physicist students from TU Dublin that came to work with me in Leiden, and then they worked already on developing some of the instruments you could use for various campaigns. So we had a drone, we have a little rover for EuroMoonMars investigation. So his nickname is Remy. We have also an equivalent of the camera for ExoMars, the PanCam, and we also have a spectrometer to analyze samples, as well as a radio antenna to observe the solar radio emission, also the Jupiter IO burst. And okay, we test that close to at ESTEC or close to ESTEC. This is some tests that we test near the DECOS spaceship on the Mars yard that we have. We even have a sea in, so we even show that our rovers can go on the beach and can be teleoperated there. And we deployed our ExoGeoLab lander to test the functioning all the operation. And we even have some candidate astronauts helping us in some of this investigation. Then we went to Etna, and this was quite interesting because at the same time, I got 5 other students starting a virtual master research with me, and I had not seen them for 3 months. But for the first time, we all met in Mount Etna, just when it was possible with the pandemics, and also with a very safe protocol for, you know, for protection, for vaccination. So very interesting logistics. And this campaign actually was organized by this young professional in terms of all housing, vehicle, logistics, vaccination, safety. And de facto, we met there on the field, either near the top of the volcano that happened to come in a new eruptive phase in this year. You can see some of the lava flow from space, and we went there joining very close to the volcano. Actually, when we arrived, the first day we went to the summit. When we went down to Catania, there was some eruption that we could witness at a distance from Catania, and it was raining ashes in our hair in the city at 40 kilometers distance. And that inspired us to go closer. So we went 4 kilometers at an astronomical observatory that is close to the source, and we could monitor then a beautiful eruption with plumes going to 400 meters height that we could even monitor with a telescope. Then the day after, when it was safe, we went to an area nearby where we could deploy some of this experiment. We simulate the landing of a small lander. We deploy a rover, a camera, and then we explore, get some samples that we analyze. Here are some of our rovers going easily down the slope, but difficult to go up. And we have our lander arriving on the surface. Look, that's how it goes. And we deployed, so this is just a series of functional investigations that simulate what a real spaceman will do, but like a training exercise for all the young professionals that have all each their task. So we deploy also radio experiment to measure the sun and Jupiter, and also in this very quiet region of Etna. So all these activities you see can be used to prepare ourselves, but also at all levels, also with young professionals, and possibly we could engage the public as well, as the Moon Village should be for everybody, for the global inhabitant of Earth that can also participate through telerobotics, through analyzing data, also just supporting this move of our civilization, expansion of humans from Earth to a double planet, Earth and Moon. And then we have all these operations to learn how to operate, how to communicate, how to survive, to use resources on the moon, as well to have a mobility, to a partnership between robots and humans, but also especially in this new space age to involve users and stakeholders that can contribute up to 70% of the overall cost and know-how of going to the moon. So that's how we're preparing for the Moon Village with a sustainable presence with human and robots. And so all the best from the team of EuroMoonMars Etna to you. And so now I'm looking forward. Oh yes, I have a little thing that we have formed an academy where we provide some complementary education to university students on this aspect of hands-on astronautics. And we have formed a network with various institutions, observatories, universities in various countries, including international space universities, Lausanne, where I'm teaching system space design, and another institution. And we love to have the participation eventually from some partners from UK universities and from the cluster of RAL. Thank you very much. You are all welcome. I'm ready for your question.
Thank you very much, Professor Foing. Absolutely fascinating places that you're finding those analogues. I'm not entirely sure that they're top of my list for my next holiday destination, but certainly really exciting places to get to go to. And I'm sure many early career people are really looking for those opportunities. I mean, what a great place to do an MSc or PhD. If I could ask the first question, and everybody in the audience, please use this opportunity to press the button and get your questions in. I'm sure that talk has stimulated lots of new ideas. But if I could ask, having done all of these analogues and having had all of these sort of experiences, where do you see the greatest challenge in terms of setting up a lunar base or going on to Mars? Is it the technology? Are there specific elements of technology? Is it the thinking, the people? What are the key obstacles that we've got to overcome over the coming years?
Yeah, so a bit like I have shown, we have the reason why we go there. There are multi-pillars. There are science, technologies, resource utilization, business, international cooperation, education, training, and even a kind of cultural renaissance. And we have to work in all these areas. And so that's what, to build a village, it takes many villages from all these different areas. And so getting the community, engaging also the community, which was not classically into space, because the moon is a surface, it's a planetary body. So there are a lot of the skill of the technology that we have developed for Earth that will be useful there. But I will see what we have to do. We have to explore the resources. And what are the most valuable resources? The most valuable resources are creative minds. We have to inspire the creative minds. And actually, this has to be at different age. So all ages are welcome for that. Those of with experience, those youngs with motivation as well. Creative mind from all countries. Also, there are some developing countries where we have also to harvest, help them to develop their creative mind, to apply it to problems that they have locally, and by trying to solve some problems or issues or challenges, as you say, on the moon, you can develop solutions for Earth. So this is what I see. And this way we can then get many people also contributing to progress on Earth, like sustainable development goals, where exploration can be a big contributor in many areas to our SDG problem on Earth. And at some stage, it will be natural to consider that, Earth moon is just a double planet system. The moon is a continent, the 8th continent of the Earth, and it will be part of our ready neighborhood.
Absolutely. And I guess just sort of building on that, because clearly exploration is very expensive. There's no way around that. But how do we make sure that we're getting those benefits back on Earth? I can see the inspiration and the encouraging the young people, but are there sort of certain areas where you think that the activities that you're doing and pushing towards the exploration goal can actually really deliver returns here on Earth?
Yeah. So as you mentioned, at the first level, education and inspiration, if I just get kids from all the world to raise their eyes at night and look at the sky, which I'm not able to do anymore from Holland, so I have to go outside to do that. And then this is how I got the bug for space. just by watching the stars becoming an astronaut. If we start that, it's already a very important thing. And then we have also to educate everybody to think with their hands. And so to do activities hands-on experimental, where they observe nature, where they look at facts, and they incorporate their fact in how they decide for their life. If we can teach this to everybody at all levels, including politicians, I think this would be, I think, a great asset. But that's very focused. There are some elements of technologies or business where there are some strong synergies. Like, for instance, we want to develop a sustainable outpost. There, we have to recycle water, we have to recycle waste, we have to grow plants. And some of these technology, for instance, the technology to grow efficiently plants in a controlled and isolated environment, this can give a yield 40 times better than if you leave it in nature. So we have a movement called new space food movement that is looking exactly at this technology in plant growth and food production, that to help the problem of food production on Earth. And actually, we had on board Martha Stewart, the celebrity chief, which has a very strong experience actually on these new technologies coming from space. And she's also a great ambassador to see how we can expand that as a solution to problem of Earth. Other aspects are telerobotics, other aspects are big data, where we solve this challenge, and they will be, of course, useful to us if they are also carried by a new population of space entrepreneurs that are going to expand all the downstream activities that are going to benefit more the rest of all the public.